Hello students, today I discuss our motion of projectile. So what is motion of projectile and its numerical form. So I have taken here two axes, x-axis, y-axis perpendicularly. So any particle if throws upward, then it goes at a height and then it falls due to the gravitational force of earth to the ground. So I have taken the maximum height the particle reaches A, and the ground where it touches again the ground at the point B. The initial velocity I have taken U. So here point of projection is O point, velocity of projection is U. Velocity of projection is U, I have taken already. Angle of projection I have taken theta. The particle is thrown with the angle theta towards upward, and horizontal range OB is maximum. I have taken R, the maximum distance traveled horizontally by the particle. So here the acceleration and the velocity can be divided into two components through x-axis and through y-axis. So velocity is velocity u have two components. Through x-axis it has u cos theta component, and through y-axis it has u sin theta component. And acceleration also have two components. Through x-axis it is fx, and through y-axis it is fy. So you can look this. Here just only gravitational force, gravitational acceleration also acting on the particle, no other acceleration acting on the particle. So I have taken fx is equal to 0, that the acceleration towards x-axis along y-axis is equal to the acceleration along x-axis is equal to 0, means in this horizontal way no acceleration is acting, but gravitational gravitational acceleration acting on a particle always on the perpendicular on the ground. So I have taken the fy component which is vertically acting on the particle is equal to minus g. Minus g means negative of g, means that it goes upward, just gravitation acting on the ground towards downward, and fx is acting fy is acting upward. So that's why I have taken fx is equal to minus g. So if these components are equal, then it can go upward. So I have taken fy is equal to minus g. So now the two components of velocity I have already taken, that ux, u cos theta in this figure, and uy is equal to u sin theta. U sin theta. Now I will find out first horizontal motion. What is the horizontal motion? Along this horizontal line, what will be the motion? So here fx I have already said that no acceleration will work through horizontal line, so it will be 0. Then I have used the fundamental formula of motion, the large velocity vx is equal to initial velocity ux plus xt. Here fx is equal to 0, so it will be vx is equal to ux or is equal to u cos theta. So this is the horizontal velocity component at any after any time t is equal to u cos theta. Now let x is the displacement of the or displacement at time t. Through horizontally, the particle travels if x is the displacement after the time t, then x is equal to the initial velocity uxt plus half fx t square by again the formula of the motion. So it will be fx is equal to again 0, so it will be fx t or ut cos theta, putting ux is equal to u cos theta. So this is the horizontal motion. Now vertical motion, what will be? Here I have already said the vertically the acceleration will be negative of the gravitational acceleration. So after time t, it will be vy is equal to ui plus fy t. Putting the value of fy, it will be ui minus gt, and putting the value of ui, u sin theta minus gt. So this is the vertical motion, vertical velocity of the particle after time t. And if the height at a time t is h, after the time t the height attained by the particle is h after t, then h is equal to will be uyt plus half fyt square. So here again I have used the formula of the motion. So this will be ut sin theta, and here it will be fy minus g, minus half gt square. Now we have already discussed horizontal motion and vertical motion. Now I wish to know what will be the maximum displacement. Yeah, this is the question. If with any angle theta a particle is subjected upward, then what will be the maximum distance it travels, and what will be the maximum height it can attain? There are these two questions. I will try to find out. So here maximum displacement I have taken r. So we have x is equal to ut cos theta. We have already find out by horizontal motion that x is equal to ut cos theta. Now maximum height, if we take h, we have vy is equal to u sin theta minus gt, as I have proved here. Vy is equal to u sin theta minus gt, and h I have already found, h is equal to ut sin theta minus half gt square. So I have denoted it equation 1, equation 2, equation 3. So at maximum height, when the particle reaches at maximum height, so there it's two components here working also. So vx and vy. So vx will be equal to 0, and vy just only works, through which it travels the distance, the rest distance. So vy works, but vx is equal to 0. So we will use at maximum height vx is equal to 0. Sorry, vy is equal to 0. Through vx it travels, vy component actually is equal to 0. There are no velocity through this component. This will be 0. For this velocity vx, it travels the rest distance, and vy actually at maximum height, since there is no component rest vx and vy, it must be equal to 0. Then it takes its maximum height, and then it comes again to the ground. So vy needs to be 0 to attain the maximum height, and vx keeps to place the particle at the ground, directs the particle to the ground at the point B. So the vertical component of the velocity must need to be equal to 0. So we will put vy is equal to 0. Then here v sin theta minus gt, vy is equal to 0. Then we will get u sin theta minus gt is equal to 0. Here t will we get u sin theta by g. So this t actually we have found out for maximum height which is for maximum height the time taken to reach the maximum height is u sin theta by g. Now h if we take the maximum height, then h we have already found that by equation 1 that x is equal to ut cos theta. So at maximum x will be equal to h. So x is equal to h and u I have taken, and t I have found out that u is equal to u sin theta by g. So we will put here u sin theta by g and then sin theta. Oh sorry, I have used this in equation 3 to attain the maximum height. X is the horizontal displacement, sorry, and this is the height. So we have to use this equation 3. So I have used in equation 3, then it will be u t sin theta minus half g t square. So I have used this will be in this form u sin theta by g minus half g sin u sin theta by g whole square. So u square sin square theta by g minus half u square sin square theta by g is equal to half u square sin square theta by g. So since sin theta have maximum value and its ranges from -1 to 1, it cannot attain more than value 1. So if we put this value sin in place of sin square theta 1, we will get h is equal to half u square by g. So this can be the maximum height of a particle based on the velocity, not on the angle of the projection. And the time of the flight, if I take t, time of the flight means that whole path OAB, if a particle takes the time t to travel, then it will be to find out this, we will have taken h is equal to 0 in equation 3. Here h is equal to 0, we have taken 0. Since you can look this at the initial point and the final point, at the 2 points the height is equal to 0, h is equal to 0. So in this equation I have put h is equal to 0 to find out the time t. So here it will be 0 is equal to ut sin theta half minus half gt square. Here t is taken common, so u sin theta minus half gt is equal to 0. So here either t is equal to 0, 1 point, this is the initial point, o point, and r, or u sin theta minus half gt square is equal to 0, which will get t is equal to 2u sin theta by g. So this is the final point or b point. This is the b point when the particle reaches the ground. So time of the flight is equal to 2u sin theta by g. So from this by equation 1, if this is the horizontal displacement, here the maximum I have taken r, so we will put r here. R is equal to u t cos theta. So we will put here u that maximum time of flight is 2u sin theta by g, 2u sin theta by g, and cos theta, this will be u square sin 2 theta by g. This is the formula of sin 2 theta, 2 sin theta cos theta. So here how we can find out the what is the angle required here some questions arise. What is that angle required to reach the maximum distance? So if we take we know that sin theta have maximum value less than equal to 1. We know that. So here, if we take theta is equal to pi by 2, pi by 2 theta is equal to pi by 2, or theta is equal to pi by 4, means when the angle will be 45 degree, then the particle reaches its maximum distance, and the maximum distance will be what? The maximum distance will be just u square by g. The maximum uh, horizontal displacement will be u square by g, and the angle required is 45 degree. So here also, so here I have taken sin theta is equal to 1, the maximum. So theta is taken pi by 2 actually. So to find out the maximum height, we need to find out at which point this is maximized. So it is another way to find out. So you cannot write down directly in this way. We have to find another way. So we will discuss this in the next video. For today, thanks for watching.